This is the Daily Space for today, Tuesday, April 7th, 2020. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. As promised, today we're going to be joined by Dr. Stuart Robbins, and my teleprompter just lost its mind, so we're going to be starting that over because sometimes that's what teleprompters do. So sorry, everyone. I'm just trying to give Susie a clean start, and when I screw up that close to the beginning, we get a redo. Hello, and welcome to the Daily Space for today, Tuesday, April 7th, 2020. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. As promised, today we're going to be joined by Dr. Stuart Robbins, a principal research scientist at Southwest Research Institute, to talk about his latest research on Mars. As always, however, we're going to start with today's news. The most exciting announcement was a surprise release from the Event Horizon telescope. Last year, this team brought us a fabulous image of light twisting around the supermassive black hole in the heart of the M87 galaxy. Now, while we're still waiting to see that image that they're hopefully gonna someday share, showing the, light being twisted around our supermassive black hole here in the Milky Way, what we have today is an image of the quasar 3C279. This image was taken in April 2017, and with this significantly more distant system, their goal wasn't to resolve the area around the galaxy's black hole. Instead, they were simply using this distant source to calibrate their systems, and along the way, they accomplished some cool science. 3C279 was discovered in 1973 to have superliminal jets. These are jets that, thanks to their alignment toward and away from us, and thanks to the time it takes light to travel, these jets appear to be moving apart at faster than the speed of light. They aren't. Nothing moves faster than the speed of light. This is just a super cool illusion. And in the Event Horizon telescope's calibration images, the team was able to resolve features 20 micro arc seconds across. That's the size of an orange sitting on the surface of the moon. Let that sink in for a moment. So in resolving these 20 micro arc second features, thanks to the massive spread of their telescopes, this team was able to observe features that in reality are less than a light year across and are very distant. By combining data from radio telescopes all across our planet, they synthesized a telescope basically the size of our planet. Over the several days of the team's observations, where they kept coming back to this calibration target while trying to observe other things, they happened to capture details around the jets of, how things are slowly changing in this galaxy, presumably due to the rotation of the accretion disk around a black hole and the shredding and infall of material. Unexpectedly, in these super high resolution images, they also discovered the jets had an unexpected twist in their shape. This is super weird, and paper lead author Jae-Young Kim describes it this way. Here we expected to find the region where the jet forms by going to the sharpest image possible. We found instead a kind of perpendicular structure. This is like finding a very different shape by opening the smallest Matryoshka doll. What I particularly love about this research is they discovered cool new science while trying to calibrate their data on other sources, once again proving that one person's trash is another person's science. These results appear in the latest issue of Astronomy and Astrophysics. From the far-off corners of the universe, we now jump to research about possible life right here in our own universe. One of the hottest topics in exoplanet research right now is modeling planetary atmospheres and trying to sort what molecules may and may not signify the presence of life. In a new paper in the journal Nature, the Horst Lab at JHU, Johns Hopkins University, explores the impact of sulfur on atmospheres. This element affects the chemistry of many worlds in our own solar system, including Earth, Venus, and even Jupiter, and it plays an essential role in the chemistry of life as an ingredient in several amino acids and enzymes. It is thought sulfur could play a role in the formation of life, and finding it in alien atmospheres could point at, well, locations to go looking for life. Alien life. According to lead author Xiao He, we found that just a small presence of sulfur in the atmosphere, less than 2%, can have a major impact on what and how many haze particles are formed. This entirely changes what scientists should look for and expect when they examine atmospheres on planets beyond our solar system. This is really cool research that involved simulating planetary atmospheres in an actual laboratory, a physical laboratory, instead of just modeling things in software. There's a lot going on in this research, a lot of chemistry going on in this research. And we're going to reach out to this team and see if they can come on to discuss this work on a future date. You don't want me trying to explain chemistry. For now, though, I'm going to answer your questions, and then we're going to have planetary scientist Stuart Robbins joining us to discuss new results appearing in JGR Planets that examines how Mars' appearance changes year after year. This is ongoing work that will lead to multiple publications and includes reprocessing Mars images from the Mars Orbiter camera to produce amazing and consistently processed images that allow us to understand variations in color and reflectivity over time. But for now, that's all I've got. As a reminder, as part of helping us all keep occupied during these really weird times, we're going to be hosting a lot of additional content here on our Twitch channel. And we want to remind you that CosmoQuest has an active community on Discord where you can talk science, volunteer for various projects, and even just find other people to join you in playing some online games. You can find links to everything that is going on at cosmoquest.org. Thank you all for being here. As I said, I will now answer your questions. But first, I need to remind you, today's script was written by me, Dr. Pamela Gay, and The Daily Space is produced by Susie Murph. The Daily Space is a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. All right, so let's see what questions we have. And a reminder, tomorrow is Rocket Wednesday, and I am so pleased to be able to tell you that Annie will be back. Yes, our own binary ablaze is once again healthy and will be bringing us rockets, including, I presume, an update on the, I believe, unchanged status. Oh, crud, I just did something that erased the history of the chat. You're going to have to retype your questions in, people. You're going to have to retype your questions in. I moved the chat on my screen and it erased the history. Yes, we have Annie out of parole. I don't think she was ever under embargo. I think she was just in jail. Yeah, she's back. She's back. Tell all your friends. And then retype in your questions. I'm sorry. Nothing launched. Oh man, that's a boring week in space science. All right. At least we really have one heck of a failed Starliner launch. That video is worth just playing for 30 minutes straight and laughing at. There were no starred questions. Okay, that's useful, Veronica Cure. Thank you. And you can go over your chemistry modules. All right. So other things going on this week. We are, as I said yesterday, going to be working to bring on more and more guests over time. And hold on. All right. Tomorrow we're going to be joined by Greg Bohr, who goes by Skull in the Stars on Twitter. He has recently put out a book on the physics of cats. Next week, we're going to be having a team of PSI scientists coming on to discuss how Mercury may once have been habitable. And as we see cool new research taking place, we're going to ask people to come on and talk about all they're discovering. If you have any scientists who you want to hear from, just let us know over on Discord and we'll reach out and see what we can do. Michael is saying he too has a chemical modeling set, so I foresee all the chemical modeling taking place. Comet Atlas is deteriorating. Oh no, I did not know that. Other space science news, the Bepi Colombo mission is going to be doing a flyby of Earth on April 10th that will be visible to people who have darkness at the correct time, which is mostly Europe, Africa, parts of the planet. This will be particularly visible with a telescope. You need a telescope to see this. If you're in Southern Europe or equatorial regions, Northern Africa, Mediterranean. And it's just kind of cool. This particular little satellite that will someday eventually make its way all the way to Mercury is going to be closer to our planet as it gets a gravitational boost than the geosynchronous satellites are. Thank you, AstroWise, for posting photos. Let me go pull up the Discord and see what I can find. Hello, Discord, my old friend. So many windows, so many windows. AstroWise, where in the Discord did you stick the photo? Probably in images. That seems like a logical place. Yes, last night's images. See the change. It is not as bright. Is it the same exposure time? So let me see if I can figure out how to bring these on. So this will take me just a moment to sort. So sorry. So here's the original image from AstroWise of Comet Atlas. And then here's the new image of Comet Atlas. It appears fainter, but I can't really see what you mean by it's falling apart. But I'm just eyeballing this. What can you tell us more about what you saw? Same settings for both. I'm hoping that it's just that as the moon gets fuller, the comet's not as bright compared to the background, and that you're losing the coma to the sky brightness. That can actually be a problem in trying to sort out diffuse objects like this in the sky. So the guest isn't on yet, Paranor, so you shouldn't be able to hear the guest yet. That's fine. I was simply asking AstroWise about the images that they'd taken that are currently up on the screen. Coma is elongated. Oh, that does mean that it's breaking apart probably. It's okay, Paranor. It's okay. That makes me sad. It appears to be a time for comets to shatter. As we talked about, I don't know if it was a few days ago or time has no meaning any longer. I think that it was Comet Borisov is the correct name for the interstellar comet that recently broke into a chunk of 2 pieces as observed by the Hubble Space Telescope. So it's a good season for comets to self-destruct. Not quite sure what that means. Images from bigger scopes now show more bits. Oh no! Do you have a link to share, AstroWise? The comet broke up, the core were elongated, and there was a decrease in gas production. Oh no. So this comet is currently not too far away from the Big Dipper. If you arc off the handle and continue following that arc, it will get you to where Atlas is. So DPI, the problem with the more bits is more bits tend to fizzle out and stretch out, and you don't get the same massive brightness on the sky. And this was supposed to be the naked eye comet that we in the Northern Hemisphere deserve. You guys in the South got McNaught a number of years ago. We haven't had a good comet since Hyakutake or Hale-Bopp. Which were in a different century, I will have you know. Poor comet. Oh well, let's see what this one is from AstroWise. Dear fellow comet enthusiasts, we may have bad news for you. Possible disintegration of comet 2019 Y4 Atlas. This is coming from Astronomer's Telegram. We report the possible disintegration of comet C2009 Y4 Atlas revealed by the public monitoring program carried out by the 0.6 meter Ningbo Education Xinjiang telescope. Next, images taken on April 5.6 to 5.9. They showed an elongated pseudonucleus measuring about 3 arc seconds in length. Oh. Okay, I'm pulling up the images. So let me bring these images over. 1 second and I'll get them to fit better. So yeah, the comet on the left is from April 3, and you can see a nice bright core. And the one on the right is from April 5 to 8. Sadness. Sadness. It is what it is. We may not get our much wanted comet. Oh well. Don't know what to say other than so long and thanks for all the hope. Sad trombones for the comet. Yes, Refs Matt. It is definitely sad trombones for the comet. Veronica, AstroWise shared for Veronica. Thank you for the follow, Marco Maroxidou. I want to say that has something to do with Mars, and I'm just not figuring out how to parse it. Can you explain your username to me? Because I now need to understand your username, you wonderful new person. So a finding chart has been shared for Comet Atlas. I'll pull that up. So there's the finding chart. This right here is 12th, 10th, Yeah, so follow that link and you'll be able to see its motion. Sadly, that will probably change now, but Ref's Matt does make an excellent point. On the other hand, people who want to use the comet as an evil omen can't do that. There were concerns, legitimate concerns, I'm afraid to say, that if we ended up with a bright comet, like the brightest in a couple decades, at the peak of coronavirus, people in a lot of parts of the world might react poorly to this confluence of events that have nothing to do with each other. So Broken Symmetry asks, will it leave dust for us to pass through in our orbit? I'd need to look at 3D models to see if the place where it fell apart was someplace the Earth will cross. I want to say I don't think this comet was at the right angle because it's up near the where it's lining on the sky, I believe, puts it out of the plane of the planets. So my gut geometry, which needs to be verified by looking at an actual three-dimensional model, my gut, based on the geometry of where it is on the sky, tells me that where it broke apart isn't someplace the Earth will pass through. And so that particularly nice blob of material that could have caused a spectacular meteor shower is not something we will get to enjoy. On the other hand, I don't know if its tail overlapped with our orbit at some other point while it was active. If it did, we will get an associated meteor shower, and that would be awesome. My gut tells me the geometry is all wrong on this system. Ark says they used Halley as an evil omen in Europe in the Dark Ages. I forgot for what. Oh, they've used comets and meteor showers as so many bad omens for so many different things. This is one of those things that's always fascinated me because I was born during the Gemini meteor shower, which once upon a time would have meant that I was born under an evil omen. And given my statistical improbability at being unable to see solar eclipses and bringing rain to star parties, it seems like a valid conclusion, but it's just statistics. There has to be, of all the human beings existing over time, each of the different possibilities cropping up. So just like you'll end up with that one impossibly lucky person occasionally, you'll end up with the impossibly unlucky person and absolutely everything in between, with most people having not a lot of positives, not a lot of negatives, and everything balancing out. So yeah. Hello, Ambius. Welcome. You must be just finishing up work where you are, or finishing up dinner, I guess. It's much later there. Welcome. Okay, so I'm going to look at the chat, see if Stuart's about ready. I'm going to take a moment to turn on my space heater because it is colder down here than I thought it would be. So any final questions, folks? Our guest is almost ready to join us, and now is a good time to bring out your questions. Okay, so I'm going to throw up the please stand by screen for just a moment. And when I return, I will have Dr. Stuart Robbins with me, and we will be talking about Mars. So don't go anywhere. And thank you, Bad Panda. And hello, Stuart. Welcome to CosmoQuest X Science Chat. We are so pleased to have you on. I've been watching you create these amazing images that you've been sharing out on Twitter. can you tell us what you are up to in your pursuit of better color images of Mars?
Sure. Although I do have to ask a naive question first. Are we actually live?
Yes, we
'Cause-
are.
Okay, because all I see on Twitch is a dog.
Oh, Twitch is a 30-second delay.
Ah, okay. Well,
It's all good. It's all good.
all right. Well, then I will avoid looking at the video on Twitch and meanwhile get to Mars. Um,
It's all good.
so I would suspect that very few of your audience remember me being on in June. Um, but when I
Because that
was
was 4 lifetimes ago at this point.
I know. I mean, the month of March was like 5 years long or something.
At
But
least, at least.
um, when I was on in June, I talked about putting pixels in proper places on planetary surfaces.
Yes.
So I was working with very high resolution images, and I was trying to get them in the right location on Mars.
Yeah.
And what I'm going to talk about today is something that I think is really interesting in the sense of this is not a research project that I was actually interested in doing or ever thought I would ever be doing.
Yeah.
But it came about because of how science works. It was sort of a natural progression from one thing to the next. And my hands look huge. Okay, I need to.
So here's the cool trip. Infinite arm.
Or my thumb is bigger than my face. Anyway,
Yeah,
sorry.
yeah.
I'm not on video very often.
That's okay.
So So what happened is after we put pixels in proper places on Mars,
Uh-huh.
the problem is that images appear to be different shades. In other words, different brightnesses. And we wanted a good way to match up the brightnesses to make a mosaic that looked good. Not just the pixels being in the proper places, but the pixels being a reasonable brightness so you could actually use them. So the problem is that there is no real good technique to do that. So we created a technique to do that, which basically works by taking a very low resolution but evenly illuminated region of Mars and then tying the brightnesses to that very low resolution, evenly illuminated area. Makes sense in principle. Problem was there was no reference source
Oh
in order
dear.
to do that.
Oh dear.
So that led me down this other side project, which is what I'm going to be talking about today, which is creating that evenly illuminated source. And so what I did was I went back in time, back to when I was in high school. Most of you probably weren't, or some of you still are, maybe not
We
even
have a
born.
very diverse audience out there. So
Okay.
they
So-
range in ages. And just to warn the audience, I'm about to blink the screen to get his images somewhere that I can share them because I accidentally tucked them behind him, which is not a good place to be able to see them.
All right.
All right.
So what I did was I went back and there is something called the Mars Orbiter Camera. And the Mars Orbiter Camera was on board the Mars Global Surveyor spacecraft. Mars Global Surveyor entered orbit around Mars in 1999 and it died in 2006. But it had this camera on it called the Mars Orbiter Camera, and it had a wide angle component. And this wide angle component let it, in a single image, take an entire strip from one pole to the other pole of Mars in a single image. And it did this every 2 hours.
Dang.
So over the course of a day or so, you could actually build up an entire mosaic of Mars. And it had two color filters, red and blue. Mars emits most of its light in red and infrared, so the red images looked better, and also the very high resolution images that we were trying to actually put in the proper place on Mars is also in red. So it would be a great source. The problem is that these data were not really processed because it was a camera that nobody really used, which is sad to say, but it is probably one of the most underutilized data sets of Mars that's out there.
So like every instrument on a spacecraft has to have a champion, that person that argues and says, did that person just like retire or something?
Oh, so now I have to be careful.
Okay.
No, The person is Mike Malin,
Hmm.
Malin Space Science Systems. They
Oh,
still produce
he got
cameras.
distracted by other things.
Yes. um, Mike, no, Mike. So Michael Malin still produces great cameras,
Yeah.
but they are. I think I can say this without fear of people not being happy with me. Um, they do exactly what they're contracted for from NASA and no more.
Yeah.
And so producing the kind of product that I wanted to make was not something that they were contracted for.
Hmm.
They were contracted to make and operate this camera.
Yeah. And
That's
they
it.
did an excellent job with that. And I
Right.
mean, let's face it, folks, it's really, really frustrating when you're contracted to do X and then everyone is like, yeah, but you need to do this thing we won't pay you for, this thing we won't pay you for, attend these meetings we won't pay you for, and you have to pay your own way there. And all of us eventually hit a point in our career when we become bitter about the amount of unfunded labor we have to supply to stay in the good graces of those around us.
Right. So it's perfectly fair, but it's still annoying.
Yeah.
If you're someone 20 years, literally 20 years later, who wants to use the data. So what I did was I went through the data set and I learned how to use it and how to process it and created these mosaics that I've been posting on Facebook and other places, and wrote a paper and submitted it in the course of about 3 weeks on the changing red color of Mars over the course of 4 Mars years, which is about 8 Earth years, or the lifetime of the mission of that Mars orbiter camera.
Yeah.
And so I think so.
You
I
sent
think
me a
it's been
bunch of
more than,
images.
yeah,
Tell
I
me what you
did.
want me to pull up, and I will pull them up.
So why don't you pull up one that's labeled either with an E or an M and then a bunch of numbers?
Okay, I'm going to pull up the E1 and switch screens.
Okay.
It is up on the screen, and they can't appreciate how long it is. So I'm going to zoom out. So it's just going to get smaller and smaller appearing. And this is because um, this is one of those super long images. This isn't even super long. This is just long. There, it's all on
Right.
the screen.
So I think it's about 1,200 pixels long, but only about 384 pixels wide.
Oh, geez.
So what it is it's a scanning camera or a scanning telescope. So it's actually just one line of pixels, and then the spacecraft moves in order to basically let it scan across the surface of the planet
Yeah.
to build up that image as it goes. And so that's why you get these really long images. Any time you see a planetary image that's really long, that's the kind of camera it is, as opposed to a framing camera, which is the kind of camera in an SLR. I can't even say an iPhone is a framing camera because an iPhone usually isn't. They're also a scanning camera. Um,
And in astronomy, some of you may be familiar with this particular technique as drift scanning. Go ahead.
so the M image, you put up the M and the E.
Right now I have the E up. Let me pull the M up.
Okay.
The M
So
up
the
is even more intimidating.
Right. Well, so the M is actually a good image. So the M image that's hopefully users are seeing or will be seeing
They are
shortly,
saying it,
or
yeah.
viewers, is a good image. Although it does have one bright line of pixels right in the middle there. But this is actually a red filter image, and it's taken roughly around equinox, so you can't actually see either pole. But at the top, you would be seeing the South Pole. At the bottom, you would be seeing the North Pole. So this is the kind of image that I was dealing with and trying to figure out how to process. And what you might notice is that it does not look like it's evenly illuminated. There's a bright sort of little speck or very elongated ellipse or oval, sort of a little bit off to the right side. And then it goes dark towards the left of that, and then it's sort of evenly illuminated across from that. This is Mars's phase function, something that probably is not something you would commonly hear about. So, a phase function is effectively how does a material reflect light based on the angle of viewing. So you can imagine, for example, a metal ball is going to reflect light right back at you if the light source is aimed right there. But if it's off to the side, it's going to reflect light differently. So because this camera is so wide angle, you are seeing the effect of Mars phase function across it. So that bright area, that little bright elongated oval, is the specular reflection. It's that bright highlight on the metal ball, or you could see it in pictures of Earth where you have that bright sort of circle on an ocean. This is Mars specular reflection, and then the other areas are other parts of that phase function. So I had to actually learn photometry, which is a whole different field, in order to try to get rid of that effect so that I could take literally hundreds of images over the course of many Mars years and average them together in order to build up a mosaic. So now, if you could put up the figure 9 image. So
Oh,
what this is the end result of all that effort with red as well as blue. What you're seeing on top is you're seeing the equinox, the spring equinox for the northern hemisphere. The lines of latitude go from about positive 50 degrees to negative 50 degrees. The image right below that is the autumnal equinox for the northern hemisphere. So again, 50 to 50 degrees latitude, but you're seeing the entire 360 degrees in longitude. And then the two poles down at the bottom, you're seeing the northern winter solstice on the bottom left and the summer winter solstice in the bottom right. And what this did is it actually taught me a lot of stuff, because not only about image processing, but also Mars has weather. Did you know
well,
that?
yes, yes. Somehow that dust storm that like totally chowed down on Mars a number of years ago may have eaten the little rover we all adored. Um, but but in creating these images, so it, I understand why you went for the two equinoxes and the two solstices when the sun is directly over the equator, when it's at its northernmost and its southernmost point. But can you explain to the audience a little bit about why it's so necessary to consider data from these particular points in time?
Because Mars is dynamic.
Yes, yes.
And what this average actually is because each of these is an average of all of the images for 2 weeks surrounding each of these times in Mars orbit. And what you can see is that, as I said, Mars is dynamic, Mars is changing. And what you can see between them, and again, because these are averages, that means this is an average repeatable weather effect. So what you're seeing, for example, in the northern winter solstice, all that white that's not in the middle,
Yeah.
those are clouds. And those are static clouds that are pretty much there all the time during this time in Mars orbit, effectively. So during the
Wait, static clouds.
okay, persistent clouds. There we go.
But
So
nonetheless, this is like, I mean, we get mountain ranges that seem to get clouds that never go away.
right,
There's a few. Explain why Mars. I'm pointing at you, not at Mars. Um,
and that's
ex-
right. I'm looking at the image instead of the camera.
yeah. How?
Same thing. So Mars has mountains. So each of these, where you can see the big white fluffiness and diffuseness, you should be able to see, depending on your screen's resolution,
Hmm.
you should be able to see a weird other colored feature, sort of where it is most white, and that would actually producing areas where clouds can form. And it does this with astonishing regularity. Because again, this is an average over 4 year that was in this data set. And so it's a persistent thing that's there. I'm getting a notice that my internet connection is unstable, so sorry if I
You
glitched.
you glitched for a moment. You're back.
Okay.
Um, so If you could just, sorry, re-explain, go back to the uh, what's underneath the persistent white clouds of awesome goodiness.
Right. So if I glitch, so there are volcanoes. It's not that the volcanoes are making the clouds, it's that the volcanoes are creating or affecting a persistent seasonal weather pattern that happens all the time during this season, every year after year after year.
Okay, I'm really sorry about that, everyone. I was switching scenes back and forth a little bit too fast for my computer to handle. We appear to be back. We're going to give a third try as the charm. We're going to try, and I'm not going to do any fancy zooming this time. We're going to try and find out about these clouds one more time. All right,
Right.
Stuart.
So big volcanoes, just like on Earth, they form weather patterns or they help form weather patterns. And because of those, during this particular season on Mars, it is very conducive to clouds forming. And to answer a question in the chat, I was not the first person to notice this, at least that I know of, but I'm the first person probably to do it with this data set. So hopefully that answers that question. Basically, I'm a Mars surface guy, and I wanted a evenly illuminated, evenly illuminated, nice, pretty picture of Mars that I could use to control a completely different data set. But in doing that, I had to develop the technique and the methods in order to process this other data set. And I did it in a completely different way than most other people because I'm not an atmospheric scientist. And most people using this data are people just looking at clouds and monitoring weather because they're interested in weather. And that's why this camera had a blue filter, is because you can see the clouds on Mars a lot better in blue than you can in red. And so the people interested in that were just like processing a single strip or like a
Yeah.
day of images and being like, there are clouds over here, and that means this. Whereas I'm like, let's make an average over 4 years and do something with it. And in doing that, it's like, wow, some of this stuff is really persistent.
Well, and
And
one of the defining characteristics of your research has been since the first day I met you when you were still a grad student and I was a very baby researcher.
we were so
Um,
young then.
we were, and so much thinner. That's the part I regret. Um,
Yes.
but one of the things that is a defining quality of your research is you fear no big data. And you will do the careful, large area analysis that is necessary to see large scale trends rather than just in the moment effects. So, from counting hundreds of thousands of craters on various objects to doing large scale mosaics and corrections like this, it's that big picture synopsis that really defines a lot of what you do. And you're finding things in your color composites that my eyeball is telling me from one composite to a next, the overall color of Mars seems to change.
And I think that's true, but one has to be careful with this particular camera because it was not well behaved.
Oh no.
And the gain information, so sort of how sensitive it was from one image to the next, could vary. Isn't published. Again, Malin wasn't paid to publish it.
Yeah.
And so I tried to do this, and I'm actually working on it now because I'm reprocessing not just a couple weeks around each of these four seasonal points, but I'm doing the whole data set now on some computers at home during this isolation phase. And I'm finding that it does appear to vary in color, but I don't know if that's because the blue relative to the red is just experiencing sort of a gain drift over the
Yeah.
course of the mission. But I am seeing a lot of interesting features. So you mentioned actually the dust storm.
Yes.
So if you were to click on, I believe, the second image that I shared with you, the one that has a
The
200 in the
200?
name.
Okay.
Yep. So if you look at that, you don't see much.
Hold on, everyone. I'll have it up in just a second.
Okay.
There.
So while you're working on
They've
that,
got
I
it.
will. I will explain that that is a dust storm.
Oh, yeah. You can just
So,
barely make out the volcanoes to the left as
right.
they kind of look like a triangle coming in for a landing in the less dusty polar region.
Right. And so the one to the upper left that is not in the row of three, that is the Olympus Mons, and then the other three are the three other very large volcanoes in this volcanic area. And you can see some seasonal frost towards the bottom, but otherwise, you'd be hard pressed to see much of anything here. And
Yeah.
that's because this is the famous 2001 global Mars dust storm. And so there was a period of actually 3 months where this craft actually did not take any data because the images would have looked much like this. So they saved money by effectively not doing anything for 3 months. There's other stuff though, and this is the reason why I'm reprocessing now the entire data set and working on a third paper on this. First one being the red color of Mars, second one being blue color of Mars, third one being let's look at all of Mars.
Oh, you needed
Um,
to do green, dude. You needed to do green. That's the
there is
series
no
of the
green.
books.
There is no green. So that was actually another story. So there's a guy who is at the University of Tennessee in some city in Tennessee, Ted Strick. You might
Oh,
know him,
yeah.
Pamela.
Yeah, he's
So
fabulous. He's a philosophy professor who's just really amazingly good at processing images.
right, so he helped a little bit with the New Horizons mission. So I knew him from that, and I knew that he had been working with Voyager data, and he had been taking two color images and somehow making red, green, blue composites. And so I asked him for help on this because you'll notice in those images you showed, it's RGB.
Yeah.
So he actually helped me learn how to create a fake, in quotes, green channel effectively by doing sort of a weighted average between the blue and the red to create that synthetic sounds better, the
Yeah.
synthetic green channel. So that's how I made these RGB composites. But I don't know, can you show two images next to each other or on top
Yeah,
of
it'll
each
take
other?
me just a second to figure out how to do it. Which two do you want?
I'd like you to show the next two, so the 310 and 320.
Okay, I can do that. They're just going to be one on top of the other. Hold on.
So while you're bringing that up, what I'm doing in this reprocessing of the entire data set for 7 Earth years or about 4 Mars years is I'm processing and averaging them and effectively build up a database of how has Mars or how did Mars change, what was seasonal, what was persistent, and what appeared to be transient. Like there's just no pattern whatsoever to these changes. So I can't tell if do you have them up.
I'm almost there. So you 310 and
Okay.
320?
Yes,
Okay, almost there. Sorry.
that's okay. So I will just describe what users, sure, viewers, not users, should be seeing in a few seconds. Um, Towards the right of the image, so at least from my camera, left, right. Towards the right, so towards the left, you have those volcanoes. Towards the right, you should see an oval towards the bottom. That's a lighter color.
Yeah.
That's called Hellas Basin. It's about 2,500 kilometers across. It's big. Above that, you will see dark areas and then light areas around it. But you'll see a dark area almost form. I'm not going to say a pyramid. Don't want to talk about pyramids on Mars. It's a separate thing. But you'll see, I'll just say a protrusion of darker material sort of up from Hellas into the northern area. And the reason I asked Pamela to display these next to or on top of each other is because that dark area changes drastically between these two images.
Yeah.
Where in the 310, it's sort of a narrow, so the one on top, hopefully, it's
Yeah.
sort of a narrow thing. Whereas in the next image, it spreads out quite a bit from there. And this happened just over a 2 week period. And because of the scale of these images, that's several hundred kilometers of Mars that just in a very narrow time period got really dark.
Yeah.
And this is a region that's been known to change in brightness a lot over the decades since people have been observing Mars, but it's just really cool to see it for yourself
And
when
this
you
is
get
an
the data.
equatorial-ish region.
Yeah, it's about 10 to 20 degrees north-ish. It's called Syrtis Major. So there are actually two volcanoes in there. They're very, very, very slight shield volcanoes. So actually, most volcanoes on Mars are shield volcanoes. So like the Hawaiian volcanoes, you almost wouldn't notice if you were walking up it, but you probably would after a little bit because you'd be huffing and puffing. Now you'd be huffing and puffing a lot more because Mars has about 0.1% of Earth's atmosphere, but that's a separate side issue. So as you would walk up, you'd barely notice it. But the thing is that there are basins. There are two big basins that border it, and there's an area of much lower topography off towards the middle of the image, and then high topography between the basins in that area. And what this does is it creates very complicated weather patterns. So if you look at models for Mars weather, in this area just over the course of not only a day, but over the course of a few weeks, they go from doing something like this to going like this to going like this and just doing all sorts of weird things. And all of that acts to change the color of Mars as dust gets deposited or dust gets blown away. And this kind of analysis, this sort of systematic analysis, I've only seen one other person do it, and it was with Viking data back in the 80s from data from the 70s. And even so, I mentioned that this is the Mars Orbiter camera on Mars Global Surveyor. There's actually a successor camera on the Mars Reconnaissance Orbiter, also built by Malin, much higher resolution, 7 colors instead of just two, not three, two, 7 colors, including 2 ultraviolet, but still nobody's doing this sort of thing. People are looking at weather again, and there are only about 4 or 5 people looking at weather with this camera. And then there was just a paper out by the guy who, the scientist who operates it. So not Michael Malin, but a scientist called Jim Bell, who is fairly famous in the Mars community. He was
He
the
did
principal investigator of the
PanCam.
rovers. I think he was the PI of the rovers in general.
I can't
Anyway,
remember. Yeah.
doesn't matter.
He
Jim
was
Bell, famous in the Mars.
he did
Yeah.
Spirit and Opie, and they're adorable and awesome, and he was friendly and took time to answer questions, and it was glorious.
Yes. So Jim Bell is sort of the scientist outside of the Malin Space Science Systems who operates the camera, and he just like literally in the last week had a paper out that was also looking at brightness changes on Mars during the 14-year data set that we now have with this Marcy camera. 14 Earth years, about 5 or 6 Mars years. And but again, he didn't look at all the colors, he just looked at the red one. So there are 6 other colors potentially for more follow-up work.
That's awesome, and I smell a grant proposal in your future.
um, that we have considered a couple.
Yeah, yeah.
Yeah.
This is
Um,
cool work.
yeah, and I'm sorry, I'm kind of going quickly. It seems scattered and not well organized and all over the place, but it's sort of like
It's
this is a neat
enthusiasm.
thing,
It's let me
and
show
yeah,
you my quarantine photos.
no, I mean I'm excited about it because
Yeah.
it's kind of one of those things where nobody's looked really at this data set, and certainly no one has processed it this particular way. And so, and again, I've been studying Mars now for a couple years,
Yeah, we'll go with
over a
that.
decade. I've been studying Mars for over a decade, but like other than dust storms, I never realized that Mars has dynamic weather, that it has these seasonal clouds that build up. I never realized that it has frost lines on the surface that you can see. So actually, I think if you were to pull up, let's see,
Which one?
pull up the first one, the 180 in the name. So what you can see in this image after you pull it up
Yep.
is not only is that Syrtis Major region now completely
Oh,
black,
wow.
so it looks very different. But towards the bottom, just below that white oval, you see almost a line. And below that, it's pretty darn white. Now, it's dirty white, but it's white, and that is a seasonal frost line. So this image is actually from data when Mars was going towards southern summer. So the southern hemisphere was coming out of winter, and Mars is tilted on its axis just like Earth is. In fact, almost the same
Yeah.
amount. Earth is 23.5 degrees, Mars is 25.2 degrees. And so what happens is you have an Antarctic circle and an Arctic circle that is in permanent night for 6 Mars months ish. And so what happens is you have this frost deposit. And again, as a surface person who just used mosaic data that other people had picked and chosen the images that I was going to use because you could see surface features really well in them, I never realized this. And I almost feel, fairly ignorant about it, but it's kind of like, this is kind of cool. And I wonder how many other people, look at these mosaics or these images of Mars at a single point in time and never realized that, even though they say Mars is a dead world, it is still crazy active
Yeah.
in terms of atmospheric interaction with the surface deposition and frost and all this other stuff, and they all interplay together to make a really dynamic place.
Now, I know you're a geology guy, so this question may be out of your scope, and that's cool. One of the questions that came up in the chat is with those persistent clouds over volcanoes, is it the same process that we get here on Earth where the humidity slams into a mountain and forms clouds with the regular wind flow during that season? Is humidity something that is that the right way? Wow.
But again, as not an atmospheric scientist, I have to be very careful to just say, I think so. I mean, there is precipitable vapor in the atmosphere. I mean, there has to be because you do get frost.
Yeah.
And so I suspect that that's the same thing that's going on here. And there is you have just that humidity, and you have that pressure density changes that just, it happens. And it's cool.
And this is cool because what this is implying is Mars doesn't have a ton of moisture, but it has enough that just like during a cool night in summer, you wake up to dew on everything, just like the right combination of weather in spring and fall. You end up with frost on the grass in the morning. You can end up with frost, but it doesn't get melted off by the sunlight on Mars.
Well, it will as it gets exposed to more and more light, but as it's coming out of that winter period, it persists for quite a few weeks.
It persists past 9 a.m.
Right. And something that I'm doing, again, with this sort of time sequence study that I'm trying to build up is I'm trying to actually see how long it persists, how long it actually takes to go away, and whether it is, or just how repeatable it is. So does it repeat the same from year to year, or how variable is it? And a few people have looked at that a little bit, but again, not in the same way that I'm trying to do it.
And the chat is just exploding with questions. So Hanny's Vorverb asks, have you ever wrapped these images on a sphere?
That was what I was going to try to do this morning in order to actually create an animation where, because I have a full Mars year processed at the moment, and I was going to try to do a spinning sphere
cool.
with a fade from one to the next.
That's super hard.
To the next, to the next.
Yeah.
And it's hard, and I couldn't get it done in an hour.
It's okay. It's okay.
But when I submit this to a journal, my plan is to actually have that as a video product that will be published with the paper.
That I look forward to seeing that and
Me too.
Having it up here on Daily Space. So another question following on that is, would you notice the frost if you were on Mars, or is it something you can only see from a distance?
I don't know the answer to that.
Oh, are any of the rovers gonna eventually go to that area? I mean, Phoenix was
pretty high north.
Yeah.
I want to say like 59, but that could even be too low.
Yeah, it was.
The rovers tend to not go far
Well,
to
they're
the poles
solar. We
because they're
like them.
solar. Right. Curiosity, of course, is nuclear powered, and so it doesn't care; it can go wherever.
Yeah.
But the science site was chosen to be Gale Crater, which is just a tiny, tiny bit south of the
Oh
equator.
no.
Yeah.
Okay. So no idea. Can't tell.
Sorry.
Um. So Larry Weird asks, what altitude is an aerosynchronous orbit? Good way to monitor Mars weather over time.
Ooh.
It's all right to not
Um.
know things. I have no idea.
Well, no. So I know where this craft was. So
Okay.
this craft was roughly a 380-kilometer orbit,
Uh huh.
but it was a bit of an elliptical orbit, and I don't know if
Okay.
that was the average or the closest or the farthest. I know
Okay.
the Mars Reconnaissance Orbiter is around 250, so
Okay.
it's even closer. And both of them took and take images at approximately the same time of day,
Okay.
roughly 2 o'clock p.m. on Mars,
And that
which is
gives you
defined.
just enough shadow to see topography.
Right, and that was actually one. So actually, I slightly take it back. Um, the Mars Reconnaissance Orbiter CTX data, this high resolution stuff I've been working with, that's at about 2 o'clock local time.
Okay.
The Marcy data, which is the successor to Mars Orbiter Camera, and the Mars Orbiter Camera took and take data at about 1 p.m. So there are very few shadows. And
Yeah.
that's actually, I think, why very, 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 very few people use these data
Yeah.
is because they're not useful for geology.
Yeah.
And most people are geology people who study Mars. And so without shadows, all you see is sort of brightness changes, which
Yeah.
doesn't really help you that much with geology. So
Right.
I think that that's why it's a very underutilized data set. And actually, so one of the reviewers of the paper that I just got out on the red color of Mars, he was and is an engineer with Malin Space Science Systems. And he actually started his review by saying, it's very gratifying to see someone finally use this data set. So
That's awesome.
it was a pretty good review, too.
Yeah, yeah, that well, you got that paper turned around so fast. That was like record-breaking turnaround.
The total time from initial submission to final acceptance was, I want to say, 4 months, which is pretty darn fast
Yeah.
these days.
Yeah, that's awesome. Let's see what other questions. Okay.
Ever have daylight savings time? I
I
completely
was
agree.
laughing at that one too.
Or time zones. I hate time zones.
Yes. Time zones are the enemy. Um so what's next?
I might
Oh,
be glitching because I don't see you.
yeah, there
Oh,
you
now
go.
I see you.
Okay. So what's next in your research?
Oh, I'm working on so many different things. um, so I mentioned the high resolution stuff. So we are working on the south pole of Mars at 5 meters. Sorry, not five, 6 meters per pixel.
Uh-huh.
That paper is in revision. I just got an extension on submitting it, so I don't have to submit it this week.
Good.
Still working on that. I'm working on reprocessing this data to get a time series of Mars. That's another project. I'm working on craters from Mercury to the Moon to Mars on a sort of a cross-planetary comparison. I'm also looking at populations of impact craters on Pluto and Charon and the Saturnian and Jovian satellites and asteroid belt and comets and doing sort of a comparison.
Wait, craters on comets.
No. So craters on the bodies and then the comet population and asteroid population and
Okay.
comparing the two.
Okay.
Um,
Okay. That
for
helps.
various reasons. Yes.
Yes.
Sorry.
No, it's all right. I'm used to measuring craters on asteroids. And then you broke me when you said comets because I thought I was following you and I was clearly not.
Sorry. The crater population versus the asteroid and comet populations.
That is.
So the things that
Yes.
form the crater.
Yes.
I'm also training to take over the radio science instrument on the New Horizons spacecraft.
Cool.
And working on various and sundry other projects. So I'm working on a lot of different intertwined things. And unfortunately, of course, I'm working on the thing that I find most interesting right now, which is this, as opposed to probably what I should be working on, which is
Yeah.
other stuff.
Yeah, it's that constant problem of being a soft money researcher where the stuff we desperately want to do, we may not get paid to do, but expletive, sometimes just gotta do the thing you're passionate about. But then there's all the other stuff we string together so that we can get a paycheck. Um,
Right.
yeah, it's our life. It's what we do. Okay. One final question relevant to our CosmoQuest community. Do you notice any interesting differences between the different planets' craters?
Yes. Sorry, I'm usually a very long-winded, so I thought I'd try to be short. Yes. So the inner solar system, the larger craters, multi-kilometer craters, look relatively the same in terms of crater population. So if you were to plot the number of craters versus crater diameter,
Mm-hmm.
it's called a size frequency distribution. Doing that for most of the inner solar system looks roughly the same until you get down to a few kilometers. Smaller than that, and things start to look very different because of surface gravity issues, distance from the sun, and other things that happen that can't be summarized quickly. In the outer solar system, on the outer solar system planet gas giant and ice giant planet moons, there we go. Um, Things just look weird.
Yeah.
You have heliocentric impactors, so that means that you get stuff that orbits the sun, like comets and asteroids hitting, but mostly comets. But we don't have the comet population well characterized, and so things look different from asteroids. But there's still some controversy about that. But you also have planetocentric impactors, so you have stuff that orbits the planet and then smashes into the moons, and those have a different size frequency distribution. And so what you see is sort of a combination of the two, and you have to pick that apart somehow. Pluto and Charon look completely different from any of those. And so we think that what those are sampling is those are actually sampling the Kuiper Belt population at small sizes, which should be similar or the same as what's hitting the Saturnian satellites, Jovian satellites, all of those. But in addition to the planetocentric ones around those gas giants. And so maybe now with Pluto and Charon, we can tease those two processes apart. That's sort of part of what this cross planetary and comet and asteroid survey is that I'm working on now.
That's cool.
But then you have further issues of scaling laws. So
Yeah.
if an impactor hits, how big of a crater does it make? And there are different authors who have published different relationships based on hydrocode simulations, so in a computer, based on other things, laboratory experiments, and they don't all agree with each other.
Yeah.
And then they also disagree with it depends on where you get a transition from a nice simple bowl-shaped crater to one that has like a central peak in the middle. And I just drew a central peak with summit pit in the middle, or wall terraces. All of those things
Yeah.
affect those scaling laws, and it gets really complicated really fast.
And then there's also just the fact that the craters look different from world to world. Vesta's craters look drunk. It not joking. These are the craters Dr. Seuss designed because this is a lumpy bumpy world that then got deformed by getting a massive crater in what is now its south pole.
Yeah, the topography of the Vestian craters is
They're drunk. Vesta, go
it's
home.
and you see a lot of them with very sharp rims along like one half and then just sloping along the other half. And I don't know what to do with those. I don't do Vesta. Vesta's for other people.
That works.
Vesta's
That
for the
works.
people who are smarter.
So I think I'm going to wind things up here because let's face it, we could probably talk forever, but unfortunately we both have other things that we are theoretically supposed to be doing that are less exciting. But this is our reality. So this has been absolutely fabulous. Can you tell people, well, one final question. Do you still do your pseudoscientific podcast?
It is on
Pseudoastronomy?
hiatus.
It's on hiatus. Okay.
It's been on hiatus. Let's face it. I'll just say after the 2016 election, when I got mildly upset with the world, and
Yeah. We all find our own ways of coping. I am systematically making my house cleaner than it has ever been. Uh, so where all can people follow your work?
Um, I'm not actually as active socially as I used to be. But I mean, so I am still on Twitter. In fact, I think someone followed me during the thing because I got a buzz on my watch. So Dr. Astro Stew on Twitter, although I don't post there very much. I do still post to Facebook under Exposing Pseudo Astronomy. So if you were to do a search for the Exposing Pseudo Astronomy podcast, there we go, on Facebook, the logo or icon is it says Bad Science with a cross out through it.
Yeah.
That's me. You can follow that page. I post there these days more than a couple times a week, including sometimes some of these images of Mars. Someone just asked, where are the pretty pictures? I'll say, darn it. That's I've posted some of them there. So that's sort of more of my outlet these days, just because it's easy. I know some people don't like Facebook. I will note that the latest version of Firefox allegedly completely blocks Facebook from tracking you.
Yeah.
So you might look at that. But otherwise, yeah, that's probably the best place at the moment.
Okay.
And I will post there as soon as, of course, as I restart my podcast, maybe after this next election. And I get less depressed.
Here's to hoping that all those things that we rage quit for a while get to come back in another year. So this has been absolutely amazing. Thank you.
Thanks for having me.
So much.
Sorry for the glitching.
Oh, it's the internet. We all glitch. It's
actually, you glitched right when you said that for me.
So I'm going to go ahead and work on figuring out how to pull the credits up in just a moment. And I'm going to boot you from the screen so that you can return to your day. And I'm just going to stick a slide up of your pretty pictures because that seems like a good way to end. So thank you, Stuart. And next time you have new results, we'll be sure to ask you back. So
thanks for having me. And thanks for people following the chat.
Go forth. Be awesome. All right, everyone. That was an amazing interview. And we'll be trying to bring you more and more of these right here on twitch.tv. As always, this has been The Daily Space with an extended special interview. We will be doing this again on Thursday when we bring Greg Gabor on to talk about gravity, cats, and the intersection thereof. Next week on Tuesday, we are going to have a gaggle of PSI scientists coming on to talk about how Mercury once may have been habitable. If there's a scientist out there doing research that you'd like to see us discuss, let us know over on Discord, and we will do all we can to help keep the science flowing. Now, up next today is Tuesday. I don't think we have anything else currently planned for today. Tomorrow, gravity and cats. Yes, Michael, I did say gravity and cats and the intersection thereof, because we all need cats and gravity. These two things do go well together. All right, so beyond that, tomorrow's morning coffee, I should be on the ball to do it. Otherwise, tomorrow is going to go very poorly indeed. So come back tomorrow at 10:30 a.m. Eastern, 7:30 a.m. Pacific, and let's ease into our day together. Share some coffee, share some science. But for now, this has been The Daily Space. Today's episode was, the first part was written by me, Dr. Pamela Gay, and this will be produced by Susie Murph. We are a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are here thanks to you. The only way I am able to pay Susie and Annie, who really, I don't get enough sleep if I don't have their help. So please, if you can, consider some bits, a sub, sponsoring us over at patreon.com/CosmoQuestX. And, well, help us all get paychecks and enough sleep. I have fantasies of enough sleep. You can make my fantasies come true. If you can't afford to help, we totally understand. These are hard times. My husband's hours were cut. We get it. We're fine. We just can't buy as much junk food. Help us out by volunteering. We have a ton of different ways for you to get engaged, and everything is listed out over on Discord. Nancy Graziano is our chief volunteer herder, and volunteers are easier to herd than cats. So find a way to get involved. We're all going to get through these times together. Anyways, have a fabulous morning, evening, or afternoon. See you.